Welcome back, focus learners, to another explainer. Today, we are tackling what's arguably one of the most profound mysteries of human existence, that bizarre, vivid play our brains put on for us every single time we go to sleep. You know, for centuries, humanity has tried to wrap its head around this, often treating dreams as this wild conduit for ancient mysticism, divine prophecies, or even supernatural visits. But today, we're going to bridge the gap between all that ancient mysticism and the cold, hard, absolutely fascinating reality of synaptic firing patterns. We're going to deconstruct the exact mechanics of the dreaming brain. Let's get into it.
Okay, let's dive into this. Have you ever actually stopped to think about how truly strange dreaming is? I mean, literally, every night you become entirely paralyzed and your brain just forces you to experience vivid hallucinations for a couple of hours. And the wildest part is that while you're right in the middle of it, you readily accept flying around, fighting literal monsters, or showing up to work completely naked as perfectly normal. So what does this all mean? Why on earth does our biology demand this super energy-consuming, intensely weird nightly theater?
Well, historically, our understanding of all this has radically evolved. Back in ancient times, dreams were seen as divine messages, right? Prophecies. Fast forward to the early 1900s, and Sigmund Freud kind of revolutionized the field by suggesting dreams were actually these highly organized, symbolic expressions of our repressed unconscious wishes. But the true modern scientific era, that really kicked off in 1953. That's when researchers Eugene Oserinsky and Nathaniel Kleitman discovered REM sleep, rapid eye movement. This was a massive game changer. It proved sleep wasn't just this passive state where you're dormant, but an epoch of highly organized, intense cellular activity. And today, thanks to fMRI and modern cognitive neuroscience, we can actually map exactly what the brain is doing.
Act 1. Deep sleep and physical repair. So before the actual dreaming begins, the waking director of your brain has to step down so the stage crew can prepare the theater. And this transition requires a massive neurochemical shift. When you're awake, your brain is just flooded with high aminergic chemicals, things like serotonin and histamine, which keep your sensory gates wide open to the outside world. But as you slip into non-REM or NREM sleep, a neurotransmitter called GABA completely takes over. Now, GABA is an inhibitory chemical. It actively dampens those wake-promoting cells, effectively slamming those sensory gates shut and plunging your brain into a deep state of quiet, physical sedation.
During this quiet little intermission, your brain activity slows way down into these rolling delta waves. But hey, don't let the slow waves fool you. This stage is absolutely critical. Your body is super busy physically repairing muscle tissue and clearing out toxic waste from the brain. It's almost like the night shift cleaning crew. It's also the exact time when your brain works on declarative memory consolidation. Basically, it takes all the hard facts and conscious memories you picked up during the day and transfers them from short-term memory over to long-term storage.
Which brings us to Act 2, the REM chemical shift.
Once all that physical repair is handled, the brain's chemistry drastically and honestly somewhat violently changes. It's like a toggle switch flips, taking you from quiet restoration straight into intense, waking-level electrical activity. You actually cycle back and forth between NREM and REM sleep all night long, hitting this toggle approximately every 90 minutes. But as the night goes on, those electric REM stages get progressively longer and longer. This is exactly why your most vivid, crazy, story-like dreams happen right in the early hours of the morning, just before you wake up.
So, the crucial point is what happens to your neurochemistry during this REM stage. Acetylcholine, which is the chemical that drives your cortical activity, spikes right back up to waking levels. Dopamine, the reward and motivation chemical, also heavily surges. But, and this is a big but, look at noradrenaline. That's the chemical responsible for stress, anxiety, and your fight-or-flight response. It drops completely to zero, literally zero. REM sleep is actually the only time in a full 24-hour cycle where your brain is entirely devoid of this stress chemical.
Act 3, logic fails, emotions spike.
Now, to understand why dreams are so utterly bizarre, we have to play detective for a second. And this brilliantly illustrates exactly what we find when we look at an fMRI scan taken during REM sleep. The brain is burning energy almost identically to when you are wide awake. You can see that in the hyperactive lit-up areas. But it does this with some very targeted exclusions, which are those dark, inactive zones.
Here's how it breaks down. First, the amygdala, that's your core emotional center, becomes up to 30% more active than when you're awake, flooding your brain with intense feeling and fear. But here is the real key to the madness: the dorsolateral prefrontal cortex. Essentially, your brain's logical CEO is completely deactivated. Why does that matter? Well, by shutting down your logic and reality testing, your brain is totally free to forge bizarre, completely unconstrained connections. This lets you process heavy emotions without any logical roadblocks telling you, hey, this doesn't make sense. Add in a highly active visual association cortex, and boom, you accept this wild internal hallucination as total reality. Now think about this. With your emotional and visual centers basically rioting and your logical center fast asleep, you are effectively experiencing a massive, full-blown hallucination. To keep you safe from acting all this out, the brain initiates a fail-safe mechanism called REM atonia. This is a state of complete muscle paralysis of your voluntary motor system. So your brain is firing intensely, literally commanding you to sprint away from that monster, but your body is completely locked down. It's a brilliant evolutionary safeguard to keep the actors safely confined to the stage of the mind.
Neuropsychologist Mark Solms hit the nail on the head here. He perfectly summarized this mechanism by noting that dreams are a delusional, hallucinatory state stoked by an abundance of the neurotransmitter dopamine. Dopamine fuels the mesolimbic pathway in the brain, specifically our seeking system. That's the core drive that pushes us to explore, interact, and crave things. And that perfectly explains why we are so incredibly motivated to interact with our dreams, even while we're laying there entirely paralyzed in our beds.
Act 4. The purpose of dreaming. As you know, evolution is ruthlessly efficient. It simply wouldn't preserve a state that completely paralyzes us and consumes massive amounts of brain energy unless it offered a major survival advantage, right? Well, modern cognitive neuroscience reveals that this nightly madness is actually highly functional. Dreaming serves as overnight therapy for emotional regulation. It acts as a virtual threat simulator to let us safely practice survival skills. It organizes our unconscious procedural memories. And by creating all those bizarre associations, it acts as a massive powerhouse for problem solving and creativity.
Let's move to and see how this builds into the concept of overnight therapy, which is a model championed by sleep researcher Matthew Walker. Here's how it works. Step 1, your brain replays an emotionally distressing memory from your waking life. Step 2, it processes this memory during REM sleep. Now remember what we said earlier? REM sleep is entirely free of the anxiety-inducing chemical noradrenaline. So step 3, you wake up with the memory safely stored, but completely stripped of its painful, visceral, emotional charge. It is quite literally a sleep-to-forget, sleep-to-remember mechanism that actively heals our psychological wounds. How cool is that? Furthermore, the structural organization of our dreams is deeply tied to something called the default mode network, or DMN. This network is what's active when we daydream or just let our minds wander while we're awake. But during REM sleep, the DMN becomes hyper-connected. This explains exactly why dreaming boosts our waking creativity, as well as our theory of mind, which is our ability to recognize and empathize with the independent minds of other people. We are literally practicing social interaction and creative problem solving inside a risk-free virtual simulator every single night.
All of this leads us to a truly mind-bending question derived from the continual activation theory. Think about this. If the brain is capable of generating such a rich, complex, and utterly convincing 3D reality entirely from within, while completely cut off from the outside world, is waking life just another simulation, simply with the sensory gates left open? Are we just always dreaming, but letting the outside world modulate the hallucination? Think about that tonight when your head hits the pillow. Thanks for joining me on this explainer, focused learners. Keep questioning, keep exploring, and I'll see you in the next one.